Hey guys! So now that we know the basics behind binary and logic gates, which I talked about in my last two videos, let's put them to work. First, we're going to make a simple 3-bit binary addition calculator. This first video is going to be going over the concepts, and I'll post another one soon about building it. Today, we'll be doing something a little bit different. My little sister will be here to help me explain. First, we gotta learn a little bit more about binary. So, when you write numbers like this, you're writing them in the system of numbers known as decimal.
Decimal is a form of writing numbers that is also known as base 10, where each possible digit place is filled with one of 10 possible values. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9.
It's a bit easier to understand when you can imagine it, so here are 3 blank digit spaces. Each number is for a space to be placed in. For every increasing space, 10 is raised to a higher power. 10 to the 0 is 1, 10 to the 1 is 10, and 10 to the 2 is 100. We'll imagine each space is like a slot in a slot machine. Each slot can be a 1, 0, 2, 3, 4, 5, 6, 7, 8, or 9. Every increasing slot refers to the power that 10 is raised to. For the first slot, 10 is raised to the power of 0. In the second slot, 10 is raised to the power of 1. And in the third slot, 10 is raised to the second power. So, the first slot will refer to the amount of 1s in the number, the second will refer to the number of 10s, and the third will refer to the number of 100s. The amount of slots can go on forever, but to keep things simple, we're going to only be using 3. Now, let's write some numbers in decimal. We'll use the numbers 1, 36, and 840 as an example.
1 would be written as 001 because there are 0 100s, 0 10s, and 1 1. 36 is written as 036 because there are 0 100s, 3 10s, and 6 1s. 840 is written as 840 because there are 8 100s, 4 10s, and 0 1s.
With binary, the numbers are in base 2, which means that they only have 2 possible values, 0 and 1. Now, instead of 10 being raised to an increasing power, 2 is the one being raised to an increased power. 2 to the 0 is 1, 2 to the 1 is 2, and 2 to the second is 4, and again, this goes on infinitely. You can imagine the meaning of each space using this reference chart. However, we're going to simplify it to only use 4 digits. Now, when you write a number in binary, you're basically adding together the numbers based on which spaces are indicated with a 1. The number 1 is written as 0001, because the number 1 consists of 0 8s, 0 4s, 0 2s, and 1 1.
The number 2 is written as 0010 because 2 had 0 8s, 0 4s, 1 2, and 0 1s.
Things get a bit more complicated with numbers that aren't 2 raised to a certain power. The number of 3 is written as 0011 because 3 is the sum of 0 8s, 0 4s, 1 2, and 1 1.
Another example is 5, which is written as 0101. 5 is the sum of 0 8s, 1 4, 0 2s, and 1 1.
Now, let's imagine some binary addition. We'll add together 5 and 1, which looks like this. Here is a helpful chart that can help with the addition of binary numbers. A and B are the 2 numbers being added together, which in this case is 5, written as 0101, and 1, written as 0001, and the sum refers to the number you will write in the equals box. The carry out number refers to a number that can be carried over to the next 2 numbers.
It's like when you add decimal numbers that equal a number greater than 10. You carry the 1.
The carry in is the number that was just carried out from the previous number. Let's do our math now.
Just like in decimal, we start from smaller numbers on the right and work our way to the bigger numbers on the left.
First, we add together the first column, 1 and 1. Using the chart, we can see that when the carry in is 0, A is 1, and B is 1, the sum is 0 and the carry out is 1. Now we can add together the second column, 1 and 0 and 0. We can see that in the chart that when the carry in is 1, A is 0, B is 0, and the sum is 1, then the carry out is 0. Now we can do the third column, adding together 0, 1, and 0. Where the carry in is 0, A is 1, and B is 0, the sum is 1 and the carry out is 0. Lastly, we have the last column. When the carry in is 0, A is 0, and B is 0, the sum is also 0 and the carry out is 0 as well. So we have our answer of 0, 1, 1, 0, which, looking back to a reference chart, we can confirm that 0, 1, 1, 0 is 4 plus 2, which is equal to 6.
The more digits you use, the more complicated it gets, which is why we're going to be keeping these numbers as small as possible and only use 4 digits in our calculator.
Now that we know the concepts, we can begin to build our calculator.
We'll be showing you guys how to do that in the next video, so stay tuned.